All right, so we are looking at linear programming, which is basically systems of linear inequalities in two variables with word problems. So here's our first word problem. Jason is buying wings and hot dogs for a party. One package of wings costs $7. Hot dogs cost $4 per pound. He must spend less than $40. Write an inequality to represent the cost of Jason's food for the party. So before we can begin, we have to figure out what's going to be our x and our y if we're graphing this. There's no true independent, dependent variable here. Our variables are wings and hot dogs. So I'm just going to make x equal packages of wings. I'm going to make y pounds of hot dogs, and I should put packages. So how many packages of wings and how many pounds of hot dogs we are buying. We're buying in bulk because we're having a party. So if we're writing an inequality to represent the cost of Jason's food for the party, we have to go back here and look at this again. One package of wings costs $7. Hot dogs cost $4 per pound.
Oh, 7x and plus 4y.
Plus 4y. And he must spend less than $40. Well, that pretty much gives us the symbol, doesn't it? Whatever he is spending has got to be under $40. So there's an inequality that we will graph in a little bit. And then if we go down through the rest of this, it says Jason knows that he will be buying at least 5 pounds of hot dogs. Write an inequality to represent this situation. So this just has hot dogs. It's just going to have y. If he's doing at least 5 pounds, that means he's going to have 5 pounds or more. So if y is the pounds of hot dogs that he's buying, I'm going to have greater than or equal to 5. Does that make sense to everybody? And then it says we're going to graph both inequalities, shade the intersection, identify two solutions, and justify our answers. So we have to ask ourselves in this situation if we can have any negatives. Are we going to have negative pounds of hot dogs? No. So sometimes they will actually go through at the beginning and say x is greater than or equal to 0, y is greater than or equal to 0, and make that part of your constraints. The way that I like to handle that, if we know that everything is positive, I just put the x-axis at the bottom of my graph and the y-axis at the left edge. And that way I don't have to deal with anything negative, and I don't necessarily have to graph where x and y are positive. But you may see, especially if you go into college algebra, they may actually shade on a 4-quadrant graph so that you end up knowing that your solution is in the first quadrant. If I know everything's positive, I tend to just make this into a first quadrant graph. Okay, so for wings, I'm going to space this out just a little bit. I'm going to go 2 spaces for 1, 2 spaces for 2, 2 spaces for 3. Be careful and make sure you are consistent, numbering all the way across. And you want to use as much of your graph as you can. So I went up to 10, and this would be packages of wings because we said x was packages of wings. So I'm just going to put that down here on my label. And then I'm going to do something very similar for y, which is my hot dogs. So I'm going to do 2 spaces per unit, 3, 4, kind of running into this. I'm going to move this out of the way. So y is greater than or equal to 5. I'll write that over here so that I can make this better. 5, 6, 7, 8, 9, 10. So this is pounds of hot dogs. My son loves hot dogs. They're so gross. So I don't buy them and cook them very often. But, all right, so we have it set up. We've got everything labeled. Now we just have to make our graph. So this first one that we wrote, the 7x plus 4y is less than 40, we will have to rearrange. So think about the song. We add or subtract the x term.
divided by the coefficient of y.
I like it. Okay, so we're subtracting 7x from both sides, and then I'm just going to, I don't have a lot of room, so I'm going to put it over here. So 4y is less than negative 7x plus 40. I just put the x's in front because that'll be my slope when we're done.
Now you divide by the,
And then divide everything by 4, and I'm going to try to rewrite this. So y is less than negative 7/4 x plus 10. I'll just circle that. It is kind of small. Let me zoom in on that just a little bit. So 40 divided by 4 was 10. So I need to start my graph all the way up at 10. It probably would have been a good idea if I'd rearranged this first, because at this point I might realize, oh, I have to change where I start my graph. But we're good. It'll start at 10 and then it's going to go down. 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3, 4. So I counted the way that I had it labeled. But the freaky thing is you can also do that with boxes. 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3, 4 like this. Yes. And I'm ready to pass that on if you just want to
I'll take it. And give it to Natasha maybe?
Yes. Okay, so this is what we've got of the graph so far. And I can't get another point going this way, so I'm just going to graph what I have.
it's dotted.
And it should be a dashed line. We know that because it doesn't have the equal to, dotted, dashed, whatever. So we're going to do this, and it's going to cross the x-axis just a little bit before 6. And then we are going to shade under. So I just like to take my pencil and shade parallel to the line, like this. It's not very colorful, but makes it show up just a little bit. All right, and then our only other constraint, they call these constraints because this is what's sort of limiting where our solutions are, is y is greater than or equal to 5. So if we think about Hoy Vux and the things that I've taught you with horizontal, vertical, this has to be a horizontal line. So at 5, I'm going to put a solid horizontal line. Solid. And then because it's greater than, I'm going to shade up. So if I shade horizontal, it'll go like this. So my solution region is going to be this triangle, and it's just customary to go back and color that in really dark so it's really obvious that that's where our solutions lie. So there's lots of different possible numbers. You know what I forgot to do? I forgot to make this line dashed.
Yeah.
I'll go back and try to do that a little bit.
That's irresponsible.
I was getting excited about getting the line in. So this is a dashed line. So our solutions are inside this triangle, and then anything on the solid line here would also be a solution. And anything that's on this line would also be a solution because we did talk about to be greater than or equal to 0. I could buy 0 wings. That is an option. So we're supposed to identify 2 solutions and justify our answers.
Oh.
So that means we're going to show a little bit of work. So we need to find combinations of wings and hot dogs that are in our budget that work. If we're trying to do this for real, we're probably going to try to get the most of both that we can. So I might go over to like where 2 packages of wings are and go up right here to 6. So this might be a solution that I would try. So I'm just going to mark that 2, 6 would be a solution. So if we think about what that represents, 2, 6 is a solution, but since this is a story problem, we have to know what that means. So that means I'm getting 2 packages of wings and 6 pounds, I should put in 6 pounds of hot dogs. And when it says justify your answers, we just need to show that this is going to work with both of our constraints. So it already works with it's greater than or equal to 5. So we can just put 6 is greater than or equal to 5. I'm definitely buying more hot dogs than I said, or that Jason is buying more hot dogs than he said he needed. And then we need to put this into the inequality for the price and just make sure he's under $40. So if I take 7 times 2 and 4 times 6, I get 14 plus 24, and it comes out $38, which is just under his $40. So that all checks out. So in justifying my answers, I could write out a little sentence or two saying, or I could just show a little bit of work here. I'll let you guys do either. But I made sure to detail what the 2-6 means. Okay, so give me another solution. What would be another one?
0, 10.
0, 10. So 0, 10 is on this dash line.
Oops. Okay.
So we might want to stay away
Let's
from
go
that.
0,
3,
9.
5.
Okay, 3, 5. 3, 5. Actually,
On the
I don't think
line.
I think it's just a tiny bit underneath the line.
What? No
See this?
way.
It looks like it's under the line for me. Now you could test it to
0, 9.
see.
0, 9.
09 is for sure on there, so I'll do that one. And if you want to test the 3, 5 and see if it works, you can. So this would mean I am buying no wings. I'm just going to buy 9 pounds of hot dogs. So you could quickly go, okay, so 9 is greater than or equal to 5, so that checks out. And then when I'm putting it into my formula, I don't have anything here. I'm really just going to do 4 times 9, which is 36,
It is 1
and that's
over.
under 40. It is,
It's 1 over.
okay, so it didn't quite work. So Adrian just tested 3, 5, and it came up with $41. So it didn't quite work. So this is why they want you to justify your answers. You have to make sure it's staying under the $40 and that you are satisfying the constraint that it's at least 5 hot dogs. Okay? And what I'm going to show you in a little bit is how to find the best solution. But for now, we're just going to look at some solutions. All right. So the boys and girls soccer clubs are trying to raise money for new uniforms. The boys soccer club is selling candy bars for $2 a piece, and the girls soccer club is selling candles for $4. They must raise more than $800. So it says write an inequality to express income from the two fundraisers. So again, this doesn't have a true independent dependent, so we can just assign X and Y. Typically, you just go in the order that they show up in the problem. So the candy bars show up first, so I'm just going to say X is the number of candy bars, and then Y would be candles. And it's just the number of each. So if you want to put a little number hashtag sign in there, that works. So it says write an inequality to express the income from the two fundraisers. So the candy bars are $2 a piece, and the candles are $4 a piece. So 2x plus 4y. And they must raise more than $800. So more than would be the same thing as greater than. So whatever they're raising with the $2 for each candy bar and $4 for each candle, this part's got to be bigger over here than 800. And then it says the girls expect to sell at least 100 candles. Write an inequality to represent the situation. Yeah, so y is greater than or equal to 100. So very similar to the last one. It says graph both inequalities on a grid and shade the intersection. Give 2 possible solutions. Justify your answers. So what we are going to do before we make our graph this time is we're going to rearrange this equation so we'll know how high that one needs to go. I know this one needs to go to 100. So I know we're not going to number by ones, but I need to see how far this one's going to go up. So if we rearrange, we can subtract 2x from both sides. We'll get 4y is greater than negative 2x plus 800. Divide everything by 4. And
200.
yeah, so we get y
1/2.
is greater than negative 1/2 x plus 200. So I sort of went up here so I'd have room to write it out. So I know I need to go up to at least 200. In the spirit of just having a little bit of extra space, maybe we'll go up to 300. So I think I'm just going to go up and make 6, 7, 8, 9, 10. I don't want to go 10 spaces for 100. Although I could. I think I'll just go 1, 2, 3, 4, 5. I'm going to go up 5 spaces and call it 100, and then another 5 for 200. That way I can go just 100 past and we're okay. And this would be candles for our Y. And then we'll do the same thing over here. You do not have to number the X and Y axis the same, but if you don't, you have to be really careful about how you graph the slope. So I guess I'll go ahead and go over to 400 on this. And so this would be candy bars. So we just graph our two inequalities. So the first one is -1/2 x plus 200. So I'll start at 200. And because the X and Y axis are numbered the same, you can just go by boxes, down 1/2, down 1/2, down 1/2. You could actually go down 100 and over 200 because that fraction reduces to 1/2. If these were not numbered the same, we would have to make sure that we were going down 1/2 using the numbers. So that's why I like to keep them the same units, the same spacing on both. And then, is this a solid line or dashed?
Dash.
Dashed. All right. So we'll dash it, dash it, dash it, all the way down. And then we want this to be more than, so we're going to shade above the line. So I'm going to shade this direction. Don't have to spend a lot of time coloring that in. You can if you just really like to color. But the big thing is just making sure that you know where the edges of everything are. Now it is going to stop at the X and Y axis. I guess I didn't talk about that, but we're not going to have any negatives. So this is my X axis. This is my Y axis. Okay, and then we're going to do Y is greater than or equal to 100. So I'm going to put that horizontal line this way, and we want it to be shading up. So if we shade above and look at where they cross, my solution region is going to be all of this. Okie doke. So this is my solution up here to the edges, and this actually is what we would call an unbounded graph. Really, the sky's the limit. They can sell as many candy bars and as they want, but we have some lower limits here. Anything down here on this line is going to be exactly $800, so they don't want to be on that line. They want to be past it.
I feel like in real life nobody would buy the dang candles. All they would get is the
You'd be surprised. Scented candles actually sell pretty well. I've done fundraisers where we sell those. It's all the moms that buy the scented candles.
Yeah, my mom has like 20 and she never lights them.
Yankee candles.
Yankee candles. All right, so let's find two possible solutions. So give me a possible solution.
Okay.
230.
So 200,
Oh, 300, my bad.
200, 300. Okay, so 200,
My
300. It's okay. You just left a zero off. I'm like 230 would be.
100, 300.
So this would be 200 candy bars and 300
Wait, 400.
candles. So it could be anywhere out here. They did 200, 300, which would be, huh? So it can be anywhere out here. This is the point he chose. And so you can make sure that that works. Obviously, the 300 is bigger than the 100, so you could just write that somewhere. 300 is greater than or equal to 100, so that checks out. And then you could look at the money that they're bringing in. It's $2 for each of 200 candles, and $4 for each of candy bars candles. So this would be 400 plus 1,200, and we'll end up with $1,600. So that's double what they want. That's definitely greater than $800.
Definitely.
So we can check that off.
Definitely. Yeah, that's right on, brother, for that one, dude.
So then, what other point did you guys want to do?
400, 100.
Okay, what was yours?
400, 100.
400. 400, 100 is on this line, so it does work. So 400, 100 is on this solid line down here, so you picked one right on that line. So that would be 400 candy bars and 100 candles. So the 100 just barely meets the qualification that he has to sell at least 100 candles. The reason why they sometimes put those limits on there is sometimes if you sell at least 100, then you don't have to pay for the shipping for them to come in. There may be some other incentive. Like maybe you get bonus money. Sometimes they'll add a percentage on. Yeah, something like that. And then to look at how much they're going to make, we would have $2 for each of 400 candy bars, and then $4 for each of 100 candles. So this would give me 800 plus 400, which is $1,200, and that's definitely over the 800 that we had, so we can just check that off. So if you would rather write sentences out to justify, that's fine. If you just want to show your work, that's fine too. Okay, so
You let us do this further.
I'm actually going to change the next problem a little bit, and then I will give you the last one for practice.
It's time to go.
Yeah, it's already.
Oh, it is time to go.